Hey guys, welcome back. In this video, we're going to be doing usubs dealing with exponents. So we could never integrate e to an exponent other than x to the first power because this says 3x plus 1. Okay, what we're going to do is we're going to set that to u. So we're going to say let u equal 3x plus 1. Let du dx equal to 3. Let du over 3 equal dx. And then we're going to go back. E to the u du over 3. You're going to factor out the 1/3 e to the u du. Who gives you e to the u? E to the u. So you're basically done. You just have to substitute 3x plus 1 back plus c. Okay, that's how easy it is. So remind yourself that when you're doing a usub, your base angle and exponent is going to be your u, and if your angle or your exponent is something other than just plain old x or theta or just a single variable to the first power, you need a usub. Let's try this one. There's a whole bunch of things wrong with this problem. First, it's a product. Second, the exponent. So who should be our u? The exponent. What's a fast way of identifying that? Well, this is x to the third. It's exactly 1 higher than x squared. So we're going to let u equal to x to the third, du dx equal to 3x squared, du over 3x squared equals dx. Then you're going to go in order. That's just x squared. That's just e. This exponent now becomes u. And dx is this person here. Now, the 3 is okay to stay because it's just a constant or a coefficient. So that's just going to go out in the front. The letters must exit. So these cross off. You're left with e to the u. Again, who gives you e to the u? E to the u. So we have 1/3 e to the u plus c, and u is x to the third plus c. So I hope you get the idea. You can't have products or quotients. You need a usub. Here again, this is a product. The e has an exponent. And some of you may have guessed it. U is going to be your sine x. Du dx is equal to cosine x. Du over cosine x equals dx. You go in order. Okay, so cosine, that's there. E, that's there. This is u. And then dx is this guy. These cross off. Perfect. Who gives you e to the u with respect to u? E to the u plus c. U is the same thing as this person. So, e to the sine x plus c. Okay, let me just see what's left. Yes. So sometimes teachers fail to let you know that the derivative of e to the x is e to the x times the natural log of e. The reason why they don't mention it is because when natural log touches e, this entire value is just 1 because you're left with the exponent. Okay? But this is the only special case. It's just because ln of e is equal to 1. So we don't write that. When you have a number other than e, remember e is 2.718. If you have a number just like 2 to the x or 4 to the x or pi to the x, the derivative is a to the x times the natural log of a. Remind yourselves that these have to match. Again, we don't show it here because that's just 1. So if I wanted to say what is the derivative of a to the x, you would say a to the x natural log of a. That just means that if you integrate it by using the second fundamental theorem of calculus, the integral and the derivative will cancel out. You'll be left with a to the x and then the integral of this. Well, your question was, what is the integral of a to the x? Remember, natural log of a is just a number, just like the natural log of e is a number. So I divided it, and we just showed this new integral. So e to the x is e to the x, but a to the x is a to the x divided by the natural log of a. Okay? So 2 to the x is 2 to the x divided by the natural log of 2. 5 to the x is 5 to the x over natural log of 5. 7 to the u is 7 to the u over the natural log of 7. And that's how we do exponents. Come back for the next video where I show you how to change bounds. Have a great day.